I'm Anthony Yates. I'm a professor here in the department, and I actually work in applied maths. But obviously in this talk today, I'm going to try and give you as much information as we can about our course, our degree course here in Durham. And it'll also be an opportunity, if you have any questions, for us to try and answer them. So I'm joined here also by Nathan, who's one of our first year students. And so he's going to say a few words at the end. Let's see. So first question, why should you come here and why should you study maths? So I think these are actually two separate questions, but of course you should do a maths degree because you enjoy maths. If you don't enjoy maths, then you should seriously think about whether it's a good idea, because it is a difficult degree. We all find it difficult. I find it difficult. But if you persevere, it's kind of rewarding, and at least I find it a fascinating subject. And so the number one reason that you should do maths is if you enjoy it. Now, you probably haven't had experience of every possible area of maths in school, but hopefully you have enough of an idea of whether your brain kind of thinks in that way or not. On the subject of thinking in that way, the second bullet point is that you'll get a very good training. So, okay, probably most of you will never again use the specific things you learn in your degree, unless you become a mathematician. But what you will use is your kind of improved ability to sort of solve problems, to think clearly, logically, and to kind of really analyze things in detail. And I think these are skills that you are particularly sort of gain from a maths degree. Also things like computing, but particularly from maths, because that's really what we focus on. Next thing, because you'll get a good job. So I think you obviously increase your chances of getting a good job by doing a degree in a good university, but by doing a maths degree, it somehow looks even better because people know that it's a hard subject. Of course, if you want a job using maths, then it's the ideal thing to do as well. And there are, quite a lot of our graduates end up being statisticians or maths teachers or just somehow working with maths. I guess the last one is more about why to come to Durham. So league tables, maybe, I guess what this means is that somewhere we appear reasonably high on a league table. I tend to not really look at these things. Reputation, we tend to think we have a reasonable reputation as a university, but you're better off in a way going by personal recommendation. And I can say I was actually a student here, and I would recommend to come. I think it's a very nice place, and it's a little bit different from maybe a lot of other universities. Probably you've been to another talk, or you will go to another talk about the colleges and things like that. And that's kind of something that is different in Durham. In terms of maths, a feature of our course, which I'll get onto, is the flexibility. So, I mean, a lot of maths courses are quite similar in different universities, at least to begin with, but because we're quite a big department, we'll get to that, I think, that means we have quite a lot of different courses that you can choose from, essentially. So there's quite a lot of flexibility. And I guess you have to try and judge whether you like the place by walking around the town in the sunshine. So, what did I say, the department, we have 108 permanent faculty, apparently, and a number of research staff and postgraduate students. So 94 PhD students who are studying for a research degree, and another 47 master's students. So we're quite a large department. We're split, in terms of research, we're broadly split into, probably like most math departments, into pure, applied, and statistics. And maybe you have a vague idea what these things mean. Pure maths is things like, well, these are our research groups, in fact, so number theory, topology, if you heard of this, geometry, and analysis of PDEs. It stands for partial differential equations. But these are our kind of broad research groups in pure maths. This is kind of maths for its own sake, if you like. And then applied maths is where you're trying to use maths to solve problems. We have, sort of roughly speaking, 3 groups in applied maths. We have the theoretical physics. These are people doing things like quantum mechanics, string theory, and so on. We have, well, actually, my group is magnetohydrodynamics. So we're studying basically fluids that conduct electricity. So I study the sun and trying to model its magnetic field mathematically. And I have colleagues who do mathematical biology as well. So applying mathematical models to problems in biology, coming from biology. And then statistics, you probably have a vague idea what statistics is. We have groups that work on Bayesian statistics and also on more theoretical probability. So why is this relevant? Well, basically research kind of feeds into our teaching. So firstly, the courses we teach in the higher years, so 3rd and 4th year, which we'll get onto, the topics tend to be guided to some extent by the interests of our staff. And that means that they probably bring some of their kind of expertise from research directly into what they're teaching you, especially in 4th year. But also we have these final year projects, which I will again say more about, which are, it's like your dissertation where you do an individual research project. And these are very often connected with the research interests of your supervisor or the sort of group in the department. So you benefit from having a strong research department when you come to do an undergraduate degree. So we have about 300 maths undergraduates per year. It fluctuates. You've probably seen already that we have a high average UCAS entry tariff. So this is, if you look at the people who actually came, what grades did they get in A-level? And they tend to be very high, or equivalent if they're not doing A-levels. We have actually a majority of state school students. Apparently it's 80%, 20% in the recent few years. And so that's not too bad. We have the gender balance is not very even. I think this is probably the same in everywhere for maths, and it's something that we'd really like to improve, but this just reflects the people who apply and accept the offers. So that's what it is. And we have, to be honest, quite a high proportion of UK students compared to international students. We don't sort of have, we're not a strongly international university, but we have about 15% in the current first year. Not helped by Brexit, but we are trying to build this up. Okay, so when you apply on UCAS, you basically can choose, as I understand it, from these 4 degree programs in Durham. So basically there's 2 3-year degrees, the BSc, Bachelor of Science, and there's 2 4-year degrees for Master of Mathematics. So you'll see if you apply for maths in other universities, you'll see that M-Math is a national thing. It's basically a 4-year undergraduate degree where you learn more maths. But you can apply for either 3 or 4 years when you apply. The entrance requirements are just the same. Doesn't make any difference. Doesn't really make any difference to anything. You can just choose. What makes a little bit of a difference is whether you choose mathematics or maths and stats. So we have you can either do a degree where your certificate at the end says mathematics, or you can do one where it says mathematics and statistics. And that's the main difference between the two. You can change between them along the way as well, but I'll say maybe a bit more about that. But so it's not crucial which of these things you apply to be honest. But anyway, you can apply to any of these 4 on UCAS. But it's not set in stone. And it's not set in stone because they're all identical in the first year anyway. So it doesn't make any difference which one you arrive on. We don't have a separate quota for each degree or something like that. You just apply for whichever. Yes, sorry.
Is the 50-50 split on application or on degree completion?
I think it's probably both. I'm sure the number of people changing is probably about the same either way, so I don't think it makes any difference. So as I say, you can transfer between the two, and you can transfer between 3-year or 4-year up till the end of year 2. So you can really sort of try lots of things out, decide, do you really want to do this for 4 years or 3 years? If you want to transfer to the stats degree, you have to do that. You have to do the right things in year 2 already. I don't know if we have that on the slide, but we'll see, probably. Now, we do actually offer some other degrees that you can't apply to. You just have to transfer to these once you're already here. And this is basically the year abroad degree, the placement degree. So the placement degree, so the year abroad, you do 2 years here, then you take a year somewhere abroad, then you come back and do your final year, or your final 2 years if it's a 4-year. The placement degree, instead of going abroad, you just go into industry and work for a year, basically. So that's an option that you have, but you can't apply to this, or you don't apply to this in UCAS, you just change to it once you're already here. There are some requirements, so for the year abroad, if it's a non-English speaking country, then you need to have a language qualification. You would do that unless you already speak the language, you would do that in first year. What's the last one? So the MMath Year Abroad G101, this is the degree where your year, I think the marks from your year abroad count towards your final degree, something like that. So the usual year abroad program is you either pass or fail the year abroad. You don't have any marks from it that count. If you're more confident, you can do a degree where the year abroad counts, and so it takes 1 year less overall to do your MMath degree. I don't know whether you need to worry about this kind of thing now, but in case you're interested, we do have these different options. Yes, so I think if you do the other, you can do a year abroad MMath, which is 5 years, or this one is 4 years, I think, because the year abroad counts towards it. It's fairly new, but we have had a few people do it so far, I think. So how are our degrees structured? So basically, there's 6 modules per year, and it depends on the year exactly how it works. So in first year, you just have to pass the year. The marks you get don't count towards your degree. And to get to pass, you have to get 40%. And if you fail a module with less than 40%, then you get the chance to resit it in August, in the summer. And if you can, well, it's a little bit more complicated, but that's basically how it works. The other years all count towards your degree, and they're sort of weighted so that it counts more and more as you go along. So if you have if you're doing a BSc, the second year counts for 2/5, and the third year counts for 3/5. If you're doing an MMath, then it's the ratio 2, 3, 4. So I think this is probably the only maths in the talk, maybe, but we'll see. So that's sort of how it's structured. What's this? This is I guess, the outcomes of the degrees in 2021. And it's just telling you what percentage of people got which degree, I guess. Now, I feel like they don't add up quite to 100, but roughly speaking, that's what they do. So you can see a lot of people get a first, is basically the outcome of this. And the vast majority of people get at least a second-class degree, so a 2-1 or a 2-2. I'm not sure what you do with this information, but that's what it is. So what do we actually teach you? So basically, first year, there are 5 core modules, which means everyone has to do them, and one elective module. And the core modules are basically going to be very similar in every university. I don't know, it's not really going to help you to choose, but for what it's worth, you learn calculus, analysis, and linear algebra. And then, so those are all full modules, one of your 6 each. These ones are half modules, so the 4 of them together counts as 2 of the 6. That gives you 5/6, and then you have 1 in the other column. The half modules are programming, so we teach everyone to program in Python on the computer, which is sort of essential nowadays, I would go as far as to say. Then dynamics is basically what you would call mechanics in school. Probability is probability. Hope you know what that is. Statistics similarly. So we don't assume that you've done A level in any of the things like mechanics and probability, statistics. Probably you've all done some probability, but we don't assume that you did mechanics or statistics. It sort of starts from scratch, and whatever you've done before will just give you a bit of an advantage. They're the core modules, and then the elective module, you can either do another maths module, discrete maths, or you can just do something from a different department. And this is where you would take the language module if you want to do a year abroad. I guess other popular ones would be something from computer science or something from physics. You can't take absolutely anything. It has to actually fit the timetable. But people do sometimes do these other modules. So this is even if you're on a maths degree. Apart from, if you want to do lots of other modules, you should do natural sciences, which has a separate talk. So give you a bit of an idea about what comes in the years beyond this. I think we already struggle to explain to our students what the modules mean for the following year. So there's no way I could possibly explain it very well here, but just to give you some kind of flavor, in second year there's only 2 core modules, but there are 4 elective modules, and you have to do all maths in second year if you're on a maths degree. But there are quite a lot of elective things, so you can begin to say, well, I didn't like pure maths, so I'm not going to do algebra, which is basically pure maths. Or I didn't like stats, I'm not going to do stats anymore after first year. So you can already choose to a reasonable extent. And these other options are, I guess, all half modules, I think. That's why there's a gap in between here. So you can sort of mix and match these things. Hopefully by the end of first year, you're starting to get a vague idea of what you actually like or don't like. But you can basically still keep your options open if you want to and do complete mixture. There's no rules beyond the fact you have to take the 2 core modules. And the reason, what's going on here? Oh, this is the second year for maths and stats. So if you're on the maths and stats degree, then you do have to take certain modules in second year, obviously the stats ones. And so but then if you take those anyway, you can switch to the maths and stats degree at the end of the year. If you don't take them, then you can't. And you'll notice also, I guess, the complex analysis is not core for maths and stats, for what it's worth, in order to make space for the stats modules, I guess. So where it really becomes bewildering are when you get to third and fourth year, when there are loads of options, bearing in mind that almost all of these are full modules, so 1/6 of the year, and some we've sort of attempted to classify them as pure, applied, and stats. So you can do sort of all pure, or all applied, or all stats for the rest of your degree. They haven't divided the third and fourth year here, but I think it's a bit sort of academic. You can basically choose any combination of these things as long as you did the right things in second year. So if you didn't do stats in second year, you can't do stats later on, or at least you can't do all of the stats module. So I think the best thing really is if people have particular specific questions about the program, you just ask us afterwards, because I can't possibly talk about everything possible in this talk. So are there any sort of general questions? Yes? No, there's absolutely no restriction. The only restriction is that a few of the options clash with each other, because there's actually more options than there are hours in the week. But we basically try and choose the least popular combinations to clash, usually pure and stats or something like that. Yes, another question. So decision is basically what we call discrete, which is that elective module you have in first year. There's also, the further version of that is topics in combinatorics, I think it's called. Yes, the bottom one here. So we would class that as pure. It comes a little bit also into the one called operations research. Where's that? I don't even see it on here, but maybe it's disappeared off. But there's another module in the stats column that has some of that in as well. But applied is more things like mechanics or differential equations, that type of thing. He says, yes. Some things are a bit hard to categorize at some point, but so there's no restriction. You can just do any combination of these things. The only restriction is if you're on the maths and stats degree, that you have to do enough stats modules. You don't have to do all stats, but you have to do a certain amount. Otherwise, you obviously can't call your degree maths and stats. Yes?
Are there any options at Durham to do dual honours?
Yes. So we don't have joint honours. You do this via natural sciences, and if you do enough of two specific subjects, you get a certificate of that at the end. But you don't enroll separately. You would want to enroll for natural sciences. Yes, sorry. So you choose at the end of each year, or over the summer, basically, what you're going to do the next year. Does that answer your question? So you don't have to decide in advance very much, really, because it's so flexible. You don't have to really decide anything in advance before first year, as long as you want to do maths. But then, at the end of first year, you decide what you're going to do in second year. We actually let you have a few weeks to change at the beginning of the year. So you can sort of, if you go to 2 lectures and decide, actually, this was a terrible mistake, then you can change still. So it's very flexible, basically, which makes the timetabling a bit of a nightmare. So that's our main constraint in some sense. So one thing, I don't know if it was on the previous slide, are the projects. So whichever type of degree you do, whether you do an M-Math or a BSc, you have to do a final year project. And the project is actually a double module, so it's a third of the year in your final year. And this will be the case in most of the other subjects as well. Like if anyone's been to the natural sciences or physics or something, everyone has this final year project. It's like your dissertation, you would call it, in sort of art subjects. And it's highly commended by our external examiners. I think because the level that people get to in these projects in Durham can be extremely advanced. A lot of people are basically getting almost to the frontiers of current research, or even doing new research, depending what the topic is. It's one of the 6 modules. Or, well, 2 of the 6 modules, yes. It's not in addition. They didn't make that very clear on the slide. So in the final year, you do 4 of the other modules and the 2 project. And the project, you can basically just choose whichever. So the way it works is that all of us propose a topic, and then you sort of sign up for your favorite 5 topics or whatever, and you get one of them. But it's sort of done in groups, so I think we have up to 5 students on each topic. if that many people picked it. And you kind of meet together in a sort of seminar, and then gradually you kind of decide what you're individually going to write about or work on, and then you write your individual report, and you give a presentation and you make a poster. If you have a look around the department afterwards, if you go upstairs, and you sort of wander around the corridors, you'll see all these posters about maths. They're the people's final year project poster. So some of them are third year, some of them are BSc, and some of them are M-Math. But the structure is the same. The only difference between the two is the difficulty of the maths, really. Yes? Yes. Yeah, so you take exams, but in your final year you obviously have fewer exams because the project doesn't have an exam. And you actually hand the project in before the exam period. So it's, in a way, it's quite nice. You get to the end of your degree and you have a bit less to do at the end. Okay, I think I've said everything I need to say here. Any questions about this before I? Yes?
When it says final year, is that like the third year for the one who's doing
Yes. Yes, so it's the third year for the BSc and the fourth year for the... So you have to do this project in your final year. You can't do it in third year and then carry on. And so for that reason, you have to choose between the two degrees at the beginning of the third year, because whether or not you do a third year project determines which one you do. Oh, here we've got some, I don't know if you can read this, but these are titles of the projects. I think it looks to me like these are actually from this year. I think it should say 2022 to 23. How do I zoom? Sure, I have the capability of zooming in here. Oh, yes. So the fun one here is actually, these are all the titles of different projects. I don't know whether, it's just to give you a bit of a flavour. They're different every year, in particular because we have a rule that you can't repeat the same project 2 years in a row, to prevent people sort of copying each other, I guess. But they're basically all kinds of things. I think they're in alphabetical order, as far as I could see. These are the fourth year titles. What have I done here? We've got a bit of time. The most exciting one is this one that looks like a sort of typo here, which we have. This is just for fun. This is the description of this project. So this is from the kind of brochure of projects. You get a bit of a description from the supervisor of what it's supposed to be about. And funnily enough, this project is actually about encryption. So I've no idea exactly what's happened here, but apparently if you go down here, you can, this is the title of the project, you can click the crack it button, and you can watch it solving the thing. And the title of the project turns out to be Statistical Attacks on Cryptography. Now, the fun thing here is that this is actually, it's not, it's solving it in real time there by doing some kind of statistical algorithm. I don't know what, because I didn't do the project, but this is the kind of random sort of thing you do in the projects. It really can be anything from pure maths to very applied to almost sort of programming or whatever you want to do. So if you have more specific questions, I can try and answer afterwards. Oh dear, how do we do full screen on here? Apologies, I'm useless with Windows here. Edit. Right, okay. Good. So, moving on, what do you actually do on a day-to-day basis when you're doing these this degree? So, the way Durham works, another good feature of Durham is that we have 3 terms instead of 2 semesters. So you could sort of say we're stuck in the past, but we have the same system as Oxford and Cambridge. You have, we call them Michaelmas, Epiphany, and Easter term, but basically it's sort of the autumn term, the spring term, and the summer term. And the first 2 of these terms, you sort of learn stuff, and then in the 3rd term, you do some revision and then take the exams. And then we have this nice feature in Durham where after the exams, you still have 3 weeks of the term to just sort of relax and do extracurricular activities or whatever. And then you get the results at the end of the term. So we sort of have a few modes of teaching that we use. So I think the vast majority, if not all the modules, have lectures. So a lecture is basically a talk like this in a room very like this. Now most of our courses are, because they run for the whole year, they are maybe 40 or 50 lectures. So it's either 2 or 3 lectures a week, or something in between. And lectures are always 50 minutes long, and it's sort of up to the lecturer how they teach the lecture, but we usually don't do a PowerPoint presentation like this, because long experience shows that it is not a good way of teaching maths, because everyone falls asleep, and basically it's impossible for the lecturer to avoid the temptation of going too fast if you're just clicking through on a computer. So what we would normally do is write on the whiteboard or the blackboard or whatever we have. And that way it's more engaging because you're sort of making notes along with the lecturer and you're automatically going at the right speed. Because maths is too hard to kind of zip through and then look at a summary afterwards. You've got to actually go in detail through it. So that's the most popular style that we have for lectures. Yes. This is, yes, that's per module. Per module. Yes. I think we somehow have the total written. Hang on a minute. I think after this it tells you how many hours you have in a week in total. We'll get to this. So lectures are the main way of imparting information, if you like. The other way is giving you things to read. But generally speaking, you're expected to go to all the lectures, but you're not really expected to learn about things that we haven't told you in the lecture. You often need to think about it yourself to try and understand what we told you, but you're not going to be sort of given a book to read and told to go away and read it like you would be in English or history or something. Not really how maths works. The other thing we have are tutorials, which you probably have they might be called seminars if they're in other subjects, but basically it's small group sessions. And these are more interactive. So instead of you just coming along and me telling you how to do things, you come along and actually do things, and I kind of walk around and try and help you, or something like that. So they're in groups of somewhere between 12 and 20, depending what the room size is and so on. They tend to be a bit smaller in first year and a bit larger in second year. The tutor would be either one of us, one of the academic staff, or a PhD student. The students always want to be tutored by a PhD student because they somehow just sort of empathize with them more, I guess. They, closer in their career, but we only have so many PhD students, so it's a mixture of both. And in first year, you basically have 1 tutorial per module per week in the first term. So 6 tutorials. And then as you go through your degree, the number of tutorials goes down. So we sort of, there isn't time to give everyone 1 tutorial per week every single year. Our reasoning is that we give you as much support as we can at the start, and then we sort of hopefully that's a bit more effective than spreading it out evenly. But that's how it works. What they get replaced with gradually are problems classes, which I don't know if there's a slide about problems classes, but problems classes are basically sort of tutorials where more people are there at the same time, essentially. So I don't teach you something new. We work through some problems. And it depends. Maybe the lecturer will just work on the board on the problem and people ask questions, or maybe people will work themselves and the lecturer will try and answer questions. They're basically just bigger tutorials, but with more people. Extra brush up your skills tutorial. So this is just a sort of support mechanism in first year for if people are struggling. It's like another optional class they can come to get help, basically. Homework. So a more important or an important part of the degree is doing maths yourself. And so that's basically what homework is. So this is basically maths problems set by the lecturer. Tends to be either every week or every fortnight. The years 3 and 4, it's every fortnight, but in the first couple of years, it's a bit more frequent because somehow the problems are sort of easier, quicker to do. Now, a nice thing about Durham, I think, is that most of these problems are what we call formative rather than summative. So it means they don't count towards your mark at the end, which means that you can somehow, if your learning style is that you need to see the whole course before you really understand it, then that's okay. You can still pass the exam at the end. And I think, in a way, this lets us have slightly more advanced courses because we don't expect you to be able to do it as you go along. You have the whole year to learn it, and then you do the exam in May, in June. Now, for these homeworks, nowadays are a mixture of written assessments and electronic assessments. So the electronic assessments tend to be mostly in first year, and it's basically a sort of things where the computer asks you the question, you put the answer, then it gives you the feedback there and then. And it's obviously difficult to do that for more complicated questions or things where you have to write. And so those ones would be marked by the staff. Right, the advantage of the electronic ones is that you get it marked instantly. You don't have to wait a week for someone to mark it. And you can sort of try it again and things like that. So it's a bit of a mixture. As you go, there's some in second year as well, but there's a lot of courses where no one's really worked out how to have a useful electronic assessment yet. So we're still marking these by hand. But you basically have to hand in quite a lot of work through your degree, but it doesn't, the mark you get doesn't count, so you can sort of learn gradually. And because it doesn't count, we're happy for you to work with each other, of course, on it. What's this? I think this is meant to indicate how the learning process works or something. So you have the lecturer gives out what we call a problem sheet, which is a sort of sheet or a web page with all the questions on. Some of the questions you discuss in the tutorials, or you work through in the tutorials, and some of them you have to hand in for the homework. And the idea is that the tutorials somehow help you to do the homework. Not sure this slide is particularly enlightening, but that's what it is. If you add up, this is what you were saying about the number of lectures per week. If we add up the number of contact hours in first year, this is what it comes to. So the calculus and linear algebra have 3 lectures a week because they're deemed to be sort of more to learn there. And analysis has 2 lectures a week and so on. And you can see they have 1 tutorial. Probability has 2.5 hours of lectures per week and half a tutorial, but I think it means it alternates from one week to the next. Programming is different. You still have a lecture, but you only have 1 lecture, but you have 2 hours of computer lab. So if you walk around the building again, you'll see that some of the computer classrooms the programming, of course, it's important to actually try it on the computer rather than listen about it in the lecture. And so those are computer classes where you basically work through the material and the lecturer or the tutor is there to help you with it. There's also no exam for programming. It's assessed by a kind of project that you hand in. So in total, we actually gives you apparently 20.5 contact hours per week, which is probably reasonably high, but it basically reflects the number of tutorials and things that you have in the first term. It goes down. It goes down as you go through your degree. By the time you get to third and fourth year, you basically have 2.5 hours per week per module on average. And that consists of 2 lectures and a problems class, big tutorial every second week. There are some modules where it's different, but some of the modules have computer labs in the other years as well. But I think we don't need to go into that much detail unless anyone wants to know specifically. So how do we apply? I better get onto this topic here. So you apply via UCAS, the same deadline as for everything else, which is apparently January the 31st in next year. Or if you're applying to Oxbridge, you need to apply in October. But the thing to bear in mind about us is we seem to be quite slow at making the offers. So just because you haven't heard from us until March, even if you applied in October, doesn't mean we're not going to give you an offer. I don't know why this is, but somehow that's how the things seem to have worked in recent years. So bear that in mind. So what's the standard offer in terms of A-level grades is A star in maths, A star in further maths, and A in something else. So this is what you would, sort of entry requirement, essentially. So the rest of this, there are some alternative offers. So the alternative, there's a few alternatives, but the alternatives all basically, the difference is that they reduce the A star in further maths to A. Well, it can actually be the other way around, but usually you'd probably do better in maths than further maths. So we're willing to reduce one of the A stars to an A if you do something extra. And the extra thing, the most recommended extra thing is this TMUA, which is the Test of Maths for University Admission or something like that, which is a sort of test that is it's run by one of the exam boards, but on behalf of several universities, not just us. And it's if you haven't heard of it, it's basically it's a test of your sort of mathematical ability, but it doesn't require learning any extra material. It's based on what you learn in A-level and in theory in the first year of A-level, but the questions are deeper in some. You have to they're testing your understanding of it or your ability to sort of answer questions that tends to be sort of less familiar. So they'll ask something that you haven't seen a question exactly like that before, and test whether you really understand what you were doing in A-level or whether you were just sort of following a recipe. That's the theory of it, I think. I think it has 2 separate papers, but I don't fully understand the difference between the 2 papers. So that's one option. You can do that. You can do the MAT, which is some other sort of admissions test that I forget the details of, but these are things that I think that could be the Oxford one. So if you're doing that, basically if you're doing that already, then we can take that as well. And the same with STEP papers if you're applying to Cambridge. So for these alternative ones, your offer would be either this or that kind of thing. So worth saying that for this final A-level here, we don't accept general studies and critical thinking. Yes, sorry. It's sometime in the autumn, November or something like that. I think there might be another slide about it, but basically you need to go to the webpage and have a look. Let me just fit. So we've no preferences for. So the third A-level It's a bit contradictory. The only thing we don't like is general studies and critical thinking, by the look of it. It could be anything else. A-level art is as good as A-level physics, or it doesn't matter. Yes, sorry. So you can do, if you have more A-levels, we won't require anything in the fourth one, I think. You'll just have more chance of getting the A. I believe that's how it works. Contextual offers, I have no idea what that means. Sorry. No, we have the same slides for everyone who's doing this talk, but of course otherwise someone would have to do it 10 times, which is getting a bit... so now the thing, I don't know if anyone is in this category of not being able to do further maths in your school, but we basically prefer you to do the full further maths A-level, but if you can't do it, because your school doesn't offer full further maths, then we need you still to do AS level further maths. And there's this thing called the Advanced Mathematics Support Program, which I think is a government sort of funded initiative that will help you out with doing that if you're in that category. Either through your school, I'm not quite sure, or even independently of your school. So if there is anyone in that category, then you need to basically go Google Advanced Mathematics Support Program and contact them, I think. So if you don't have A-level further maths, you obviously don't have to get A star in further maths. You just have to get A in AS level, I think. But then another A in something else. Okay, if you're not doing A-levels at all, if you're doing the International Baccalaureate, then this is how many points you need. And in fact, there are also equivalent offers for other things, especially if you're in another country. Not sure how many of those people will be at this open day, but if you are, then the university will have some deemed offer for your country. And obviously, if you need to know that, then contact us. So this is the TMUA test. It's October the 18th, the test. It's actually earlier than I was thinking. So you need to register by the end of September. And there appears to be a fee of £78, but it's free if you're on free school meals or bursary support or something else. So if you go to the website for this, Google TMUA test, you'll be able to see some example past papers and all the information about it. Yes.
TMUA test, is that like if you do it, say you do terribly,
Yeah.
does it count against you?
I'm not 100% sure. So on the next slide here, it says that a good mark, which apparently is more than 4.5, will increase your chances of us giving you an offer, which I guess means if we have too many people who satisfy the thing, we'll prioritize the ones who did well on the test. But if you want to get the reduced offer, you have to get a 6.5. I'm not even sure what it's out of. 10 maybe or something like that. So I don't think it won't mean that you're definitely not going to get an offer. It'll just make it a bit less likely, depending how many applicants we have and so on, and how many of them do the test. But as I say, depending where else you're applying to, you may want to do this anyway for that. So, but if you're already doing the MAT test or the STEP papers, then they would have the same effect here. So don't do this as well. Okay. So the things that you need to get in. Okay. So mention the TMUA score. You obviously you get your predicted grades from your school, which obviously need to match the offer. Your personal statement, we look for motivation to study the program and initiative in taking your studies further. I'm not sure what that means in practice. Just write something reasonable there. Reference, we expect obviously your school to say that you're really good, which is basically the same thing as the predicted grade as far as I can see. I'm not sure what else they could say in the reference, but the quality is more important than quantity, so it's no good doing 10 A levels and getting A in all of them. We want the A stars in maths, something like that. we don't care about GCSE grades or whatever you did before you got to sixth form. Okay, so I think this might be the end of the presentation, which is just as well because we're running out of time. So I will hand over, if it's okay, to Nathan, who is going to just say a few words. So let me hand it. Don't know if you need the microphone.
Okay. So hi, I'm a first year, and I've just finished my first year, so I'm just going to give you a few bits of advice on how I found the first few weeks, because I think they're the most important to get right and settle in. So I want to talk about very, very, very first week first. So I think the most important thing when going to your first couple of lectures is just to talk to as many people as possible and just find some friends on your course, because that'll just, one, make it a lot more enjoyable and a lot less scary. Two, someone to ask for help with, because you will struggle in the first few weeks getting back into the swing of things. And also to encourage you to keep going to lectures, because attendance does drop off. And I find it so much better just going to lectures and learning from that, instead of just reading lecture notes, which are generally like quite important. Second thing is, I think the tutorials are such a key thing, and you can get so much out. So they kind of depend on the tutor about which direction you kind of take it in. Some are more interactive than others. But I'd say the interactive ones are the best ones. That you can work in the groups and find out if you actually know what you're meant to know, because everyone can help you, the tutor can help you, your peers can help you, and you can get a solid understanding for you to then complete the homeworks. And the homeworks will they're quite a lot. You just need to keep on schedule and just make sure you do everything in time and not fall behind, because then it can be quite hard to catch back up on everything. So I'd just say, make sure you use the tutorials to make sure you understand, so you can have a proper good go at your homeworks. And especially in first term, you're probably going to get a lot wrong in your homeworks. So don't get too disheartened, because at school you could be used to just getting it right straight away and finding it a bit easy. But you will get things wrong, especially in first term. So just use it as a chance to learn, and it will click for you at some point, even with some of the more difficult modules you'll find out. It will click at some point. You just got to persevere, and that's kind of part of it. That's the challenge, and that's the reward for it. And then I just think for the summer, after your A-levels or whatever qualifications you're doing, just enjoy it, just relax. Don't worry too much about being rusty on your first week back, because you've got, I don't know if it will happen for you guys, but we had like some things in September to kind of warm us back up, and then the first few weeks kind of build up from scratch anyway, and you've got the extra support classes. So don't worry too much about being rusty and not knowing much, because when you come, just enjoy your summer and